Kind greetings to you all. Mwalimu Education Services as usual. Here we are trying to break down some few concepts. Video is designed for students in advanced level. Those who are aiming for advanced chemistry. Here we are to motivate you towards learning more of advanced chemistry. Now, if you are an ordinary material, kindly look for information which is on this channel designed for your wallet. This is not your wallet. So, last time we looked at the types of covalent bonds. We explored types of covalent bonds, and I want to look at the structures of covalent compounds. Structures of covalent compounds. Now recall that examples of covalent compounds. Because that examples of covalent compounds include they include what? Water. Water is a covalent compound. Non-metal atoms. Non-metal atoms. Therefore, H2O is covalent. You have ammonia. We saw at school the formulation of these compounds. We saw them. We have which one? We have carbon dioxide. We saw all this information. It was covered. Dioxide, CO2. We have sand. Sand is the same as silicon dioxide. Same as silicon dioxide. Silicon dioxide, SiO2. There are very many. So what do I want to say that? What do I want to say? I want to say that covalent compounds can be solids. Number one. Then covalent compounds can also be gases or liquids. Kindly make this chart, make this tree diagram which I'm trying to make. Covalent compounds can be solids, like which one? Like sand. Like sand. Which other one? Diamond. Diamond has carbon atoms, which are non-metals. Graphite. Then gases like carbon dioxide. Liquids like what? Liquids like water, etc. So covalent compounds, e.g. sand, diamond, graphite, these ones, they have giant covalent. They have giant covalent structure. They have giant covalent structure. You see? Then those which are gases or liquids, they have simple molecular structures. So what are these two types of structures? Now, a giant covalent structure, this is a giant covalent structure. Now, a giant covalent structure, this is a giant covalent structure. Now, a giant covalent structure, this is a giant covalent structure. Now, a giant covalent structure, this is a giant covalent structure. So what are these two types of structures? Now, a giant covalent structure, This consists of large number. Consists of large number. It consists of large number of atoms. Atoms of nanometals. Consists of large number of atoms of nanometals linked together by strong covalent bonds resulting in a three-dimensional structure or lattice. What are the key points? The giant covalent structure is made up of atoms of nanometals. I repeat, the giant covalent structure is made up of atoms of nanometals linked together by strong covalent bonds. Atoms of nanometals. For example, in diamond, you have what? You have carbon. You have carbon linked together to carbon, to another carbon, like that, etc. So you have large number. There are very many atoms. This is just a model, etc. And those lines which you are seeing, these are the strong covalent bonds. Strong covalent bonds. Now, what is the simple molecular structure? The simple molecular structure, this is made up of molecules. Molecules of a compound, linked together by weak intermolecular forces of attraction, known as van der Waals forces of attraction. Made up of molecules of a compound linked together by weak intermolecular forces of attraction, known as van der Waals forces of attraction. So what do we have here? We have molecules. It is important to know what are the constituents of each structure. For giant ionic structure, recall from school, giant ionic structure, you have ions joined together by ionic bonds. For this simple molecular structure, we have, for the giant covalent, we have atoms joined together by strong covalent bonds. Simple molecular, we have molecules linked together by weak intermolecular forces of attraction, known as van der Waals forces of attraction. For example, in simple molecular, you have water. Now, this water is linked to another water. That water is linked to another water. And this is linked to another water. And the linkage continues. So that you have weak intermolecular. They are dotted because they are weak. Now think about this in real life. I am saying water is a covalent compound, but also sand is a covalent compound. Water is a covalent compound, but also sand is a covalent compound. You will all agree with me that it is very difficult to boil sand. It is very difficult. It has a high melting point. Very difficult. So you see, since it is very difficult, you know why it is very difficult to boil it? Because it has strong covalent bond, but it is very easy to boil water. Why, colleagues? It has weak intermolecular forces of attraction. Weak intermolecular forces of attraction. Yeah. They are known as van der Waals forces of attraction. So I have explored. Am I on? I think I am on. I have explored the two types of structures which can be formed as a result of covalent bond. Now, these are the diagrammatic representations. Diagrammatic representations. Diagrammatic representations of giant covalent structure and simple molecular structures. Diagrammatic representations of giant covalent structure and simple molecular structure. So you draw these diagrams. On one side you have giant, on one side put giant covalent structure. Then on the other hand you put simple molecular structure. Kindly make these drawings, which I am going to illustrate. Yeah, for giant covalent, these are the drawings. Make them, please. These are the drawings. Now this is for giant covalent. Yeah, so in that space where you have seen, where I have highlighted on your left where you have giant covalent, on your left where you have giant covalent, kindly make this structure. After diamond, you make the structure for graphite. You also make the structure for sand, silicon dioxide. Please do that. Make those structures. Then also, these three structures are under that column for giant covalent structure. Under that column for giant covalent structure. Then for the other column for simple molecular, you make this structure. That column molecular. Make that structure. Make that structure. And I want to stop here. Take screenshots, draw them. Yeah, in your books. So now I will stop here and concentrate on other things. We shall continue from there.